Okay, we are locked in this room. It's a small audience. Welcome, everyone. Thank you so much for taking some time out early in the morning. I hope you guys are up. If not, I strongly recommend this drink. It's much better than coffee. It gives you the sugar rush. I was having my jet lag yesterday. Basically, I had to go to sleep. I could not work on my talk. So I ended up having discovered this drink. And man, it does you wonders. I could not sleep for the whole night. So this talk is titled Windows, Azure Websites, and On-Prem Connectivity. That's the code WADB327. I just want to start off by setting some expectations on what this talk is going to be about. What are we trying to achieve in this talk so that we sort of reach a common goal, and I hope that's the goal that you have as well. Since we have a small audience, we can have a much more collaborative session, so it's a free form. There's nothing formal in terms of questions that you have to ask, so feel free to stop me. I do have a lot of stuff to go through it, but I think we should be fine. So what this talk is about is there's a perception, or actually before I start talking about it, how many people are actually building applications using Windows Azure websites? How many are building like on-prem solutions or solutions which are not on the public cloud yet? Okay. And have you guys started experimenting or started thinking about how does the cloud work, or how does my on-prem assets matter, and have people done this little bit of research around it? Show of hands. Okay. So I hope what I have to say kind of gels well, and what I hope to do as well is sort of learn from what you guys have sort of researched into and what your opinions are as well around this space. It's a relative new space. We've just launched Azure for the last few years, and now we're moving to the model of having a hybrid world where parts of your application are on the public cloud or maybe an internal cloud, and parts of your application are still on-prem. So what we foresee going forward is the applications that people might write for on-prem are going to have this mixture of what we call a hybrid model, like parts. And so that's what the talk is sort of geared around is there's a myth that if you use Windows Azure websites, then you're not building real applications. Then you're building toys. And the goal I have in this talk is sort of highlight some of the integrations that you can do with Windows Azure websites and on-prem assets. So how do I keep using my existing on-prem assets, or keep focusing on the concerns I have with my on-prem assets, while slowly using the benefits of Azure websites or benefits of the Azure ecosystem. So that's kind of the uber goal I have with this talk. The talk is not going to go deep dive into concepts like service bus or worker roles or web roles. So we're not going to have an architectural discussion around these topics. It's going to stay a level above and talk more in terms of how do I integrate my Azure websites and my on-prem assets. So how do I build hybrid applications is the goal of this talk. So I hope that's the expectation that everyone has in this talk. If not, feel free to go for a different session. Don't feel obligated to stay over here. That's the right choice. You're going to miss the magical parts, which are going to come later. There's signal R. Anyhow, so that's what the talk is going to be about. So let's do a round of introductions before we jump on to the demos. How many people in this audience are from Spain? None. Okay. My little bit of Spanish that I learned is going to go waste now. Anyhow, my name is Pranav Rastogi. I work for the ASP.NET team in Redmond, Washington. This is a team that I've been working for the past 5 years, and our team sort of owns this suite of frameworks and tools which a developer can use to build web applications. And a larger part of our team also works on solutions like the Azure Mobile Services or Kudu, which you can use for deployment. So a larger part of our org also works on this platform. I occasionally blog on my MSDN blog. I'm relatively more active on Twitter, so if you have any questions or you want to chat about, feel free to shoot me a tweet. And something I'm relatively excited about recently is I'm a newbie author. So I just co-authored my first book on ASP.NET. It's going on good. I don't expect to make my millions for the book, but it's good to have something out there. And I do have a partially funny accent because I'm not a native English speaker. Like, I'm from India. So do pardon my accent. If things are not clear or if I'm a bit fast, then please do let me know. I can slow down. And in my spare time, I do consider myself a fearless adventurer. And so this picture is something is from the fishing experiences in the Amazon, and this is me catching a piranha. I almost got bit, but that's a different story. Like, I'm still an amateur in this sport. So you're going to talk about fishing and all that stuff. We can chat about it after talk as well. So with these two bigger actions out of the way, let's sort of step into our presentation. So websites is a common understanding that I think a lot of people have, simply because of the simplicity that websites has to offer. Like, I think the general perception is like websites is for blogs and CMS application. It's for sort of the cool kids who want to do startups. It's an application model that doesn't support all of my on-prem concerns. There is absolutely no way to connect my on-prem integration. There's no logging, there's no monitoring, there is no middle tier. There's absolutely nothing. You can just build a web page, publish, and you're done. That's, I think, the general consensus that I've heard people have had with websites. And my goal today is, it's not true. What I think we want to pitch websites, or you should think about websites as a tool. It's a tool that's basically lets you integrate all of your assets, be it in the cloud or on-prem, so that you can easily build up a solution going forward. And the way to think about websites is a Lego block. It's the Lego block that I think, in my personal opinion, was missing in Azure for a long time. And folks like in the App Harbor world or in the Heroku world had this model. So it's a very viable model to have if you're building web applications. There's a picture of Starship Enterprise for those of you who are into it. And so let's talk about like what makes a platform enterprisey. That's my own word. What are the minimal requirements which you think are needed? Like, what is something that you would want in a platform that makes it enterprisey? Like, is there any suggestion on what that list would be? Anybody? Yes.
Reliability. So, like transactions.
Okay.
Databases.
Okay. I think I have one of them in my. So here's the list I thought about and I came up with. It's not the ultimate list as well, but this is what I'm going to be basing my talk on as well. I think what people really care about is in a model is they need to have distributed processing support. Not everything should be processed in my web application. It should be shared across all the tiers that I have in my application. And we got that. Should have vast storage capability. I should be able to store in my SQL servers. I should be able to store my images. I should be able to store my videos. So we should have that capability. And we still have that. Anybody a fan of Big Lebowski over here? Okay, cool. We should have a process integration. It should, an environment which is already set up, which is suited to developers. Let's say if a shop already has TFS and it's working on fine for all the builds and infrastructure. This new paradigm of following Azure websites should not involve of me rewriting my infrastructure from scratch as well. So I think we have that as well. I think the biggest one that I'm going to be focusing on in this talk is about asynchronous messaging. And a good way of thinking about this is, have you heard about this website called woot.com? Okay. Have you heard about amazon.com? Okay. Cool. So think about amazon.com and think about what happens during Christmas time or New Year's. Like the number of orders that are placed on Amazon just like skyrockets. And how does Amazon.com handle it? Like they've obviously split up their application in such a way that their web app is not processing all the orders. The processing of the orders is happening in some other tier. And there is some asynchronous messaging that's happening between the tier that's processing the messages and then the website is actually displaying the UI and stuff. So you definitely would want something like that to make a platform more enterprisey. And Mr. Chimpanzee says we also have that. And another big thing that's sort of becoming a lot more popular now is federated identity and access control. And what this basically boils down to is with the integration of Active Directory, users want to be able to carry their identity in an enterprise across the different applications that they're using. So I should be able to log in with my domain account across these apps and then sort of carry my identity forward. And Mr. Borat says we have that as well. So how do we have all of this? The way to think about it is like we have distributed processing support in the form of cloud services. Have folks heard about cloud services in terms of web roles and worker roles? So these are basically worker roles that you can have running in the background that can process a task for you in your web application. We have storage capabilities in the form of Azure SQL Server or like blobs or queues. So we have that. We have process integration in Azure by the way of TFS. So you have TFS Online. You can set up a CI server based on your Kudu deployments that can do a poor man's CI. I have a talk on Friday where I'm going to go a deep down onto how you can use Kudu for customizing your deployments. And then we have a service bus, which is great for asynchronous messaging between the different tiers of your application or between your Azure websites and then the different tiers in your application. And in I think a month back or something, I think Azure GA'd the Active Directory on the cloud. So now you can sign up and get a free Active Directory on the cloud for free. Like that is pretty awesome. So that's kind of the pillars that sort of Azure provides, for somebody who wants to write an enterprise application. And in this talk, I'm going to be focusing more on column 1, which is distributed processing support, and then column 4, which is asynchronous messaging on service bus. I'll show you a little bit about SQL storage and how we can use SQL storage. And so that's going to be the remainder of the talk. So the way I'm going to approach this, these sort of the demo parts is basically think about an app that you might write. And I could have done a traditional forms over data application, but that's boring. It doesn't lead to anything. So what I did was, and this is just came out this one weekend, I was sitting with a friend of mine, and I think it was a national holiday. There was nothing open, so we had to order pizzas. And so we went to a site and ordered pizzas. And that's how this idea came up. Let's say I have to make an enterprise app for a pizza company. Okay, so think about Pizza Hut. And so what happens is, as a user, I go to a website where I can go and choose my pizza, I can order pizza, I can place an order. And once I place an order, things happen in the background. An order goes and gets submitted, some credit card verification happens, then an inventory management happens, like who can provide the order, and then some billing happens. And then there is different locations where a pizza can come from, so there is some monitoring that the headquarters does of what pizza location is making how much of business. So that's kind of the overarching app we'll try to make in the next 40 minutes. So the first basic scenario that I want to start up with the requirement is I just want a website where a user can go and sort of order a pizza, and that's it. That's the first step that I want to provide in my application. And the workflow for that is kind of very simple. I go to a website, I enter some details, and I persist that data into a SQL Server database. So let's see how the code for this could look like. I basically have 2 projects. My data access layer is based on Entity Framework. So I have my models class, which are POCO classes. I basically have pizza, some sections, some ingredients, and then I have my DB context, which basically has the DB sets of all of my POCO classes. I'm using EF migrations to seed my database. Have people played around with EF over here? Okay. There was a talk by Glenn Condron yesterday. I think it's going to be recorded, and he might have another rerun of the talk if folks are interested in that. So once I seed my database, my application database kind of looks like this. So I have a pizzas table, and I have a pizza orders, which basically stores the orders information. When I order a pizza, I can split the order into the following ways. I can say half of my pizza, I need chicken, and half of my pizza, I need pepperoni. So I can divide my pizza into sections. So that's why I have this table called sections, and I have ingredient selections, which are basically for what section do I need what ingredients. And then I have an ingredients table, which basically says, like, what are the toppings that I can add to my pizza. So that's kind of what my database looks like. If I execute my query, right now it's all empty, so there's nothing in the database except my ingredients. So that's my backend. Let's look at my UI. This is the UI is an MVC4 application. There's nothing special about it. There is my home controller, and what I'm simulating over here is, like, I don't have a UI where a user can go and choose a pizza and can choose the ingredients, because that's not relevant to the demo. Like, let's say that happened and somebody placed an order. What I'm simulating over here is what happens when the order gets placed. So in the simple case where a user comes in and sort of orders a pizza, I randomly create that order, and I can save the order into the database using my EF query. So that's what the app does. So if I launch it, I can click this button to cause the simulation of ordering a pizza. It's a very fancy UI, and the sample order is placed. So if I go back to my database, I can now check my pizza orders, and I can see what happened, basically. So I placed one order of pizza, and that's it. That's it. So nothing special about it. It's a standard run-of-the-mill web application where a user can come in and sort of place orders. What's wrong with this application? Anybody want to take a guess? Too simple?
Can get overloaded when there are many requests at the same time.
Perfect. Yes. Thank you. Yes, that's the number one aspect which is wrong to the application is think about the Amazon scenario where there's a spike in the ordering of the pizza. There's a game. And if there are too many requests, some orders might get lost or the UI might get slow. So we need to separate out this concern of ordering the pizza, the placing an order, and the processing of the order. So right now, both these are happening in the same application. So what we're going to introduce in this next demo is a middle tier. And middle tier is not in the terms of, like a pure database, two-tier application or three-tier application, but middle tier in terms of the layers which can exist in your application. So my website earlier was basically writing to the SQL database as part of one step. But now what's happening is I'm sort of introducing this layer called queues, which is an Azure concept. And so my website is going to write to the queues, and there's going to be some worker running in the background that's going to process the queue and then write the results to the database. So I'm sort of creating the separation of what the website can do and what happens in the backend. And then slowly, we're sort of going the direction of I'm going to start merging my on-prem assets. And so let's switch back to the demo. Let me close this. And so let me walk you through what changes are there in this particular application. So first, I've added a cloud services project into my application. And all this project does is basically it says that I have a worker role set up into my application. And this worker role is going to process all of the background tasks. I'm going to look at the worker role in a sec. My data access layer stays the same. It's still entity framework based over here. And I've added this infrastructure project. And this infrastructure project is basically a convenience layer that I have added that can talk to queues. And the reason I've sort of set it up as a separate project is because I wanted to reuse the code both with my web application and in my worker role as well, because my web app is going to write to the queue, and my worker role is going to read from the queue as well. And all this does is basically it opens up the queue and it writes to the queue and then sort of reads from the queue as well. So those are three high-level functions that it has. If I look at my web application in my home controller, so you would see that I no longer have the code to persist in the database. Instead, what I'm doing is I'm writing it to the queue. And the way I'm writing it to the queue is I'm sort of serializing my order into JSON using JSON.NET. JSON.NET is a popular library. It's an open source library for dealing with JavaScript and serializing into JSON and stuff. And so my web app is now basically writing into the queue, and I have this worker role, which is going to read from the queue and then do something with the results. So all it has is basically two methods, like onStart, which is called the first time it runs, and then run, which does the actual processing. So basically, it's an infinite loop, so it keeps on running forever. And it listens to the queue. Whenever there's a message on the queue, it reads it, and then it deserializes the JSON back to a pizza order, and it sort of saves the changes in the database. So that's how I've sort of separated this concern of what the processing was happening in the website is now happening as part of the worker role. So let's run our application as well. I'm going to clean up my database. So let's start the web role. I've not set up all the projects to launch in a simultaneous manner, so please do bear with me as I do this. Okay. And so what happens when I do run the cloud project is it deploys the application locally. It starts up the Azure emulator so that I don't have to deploy it to real Azure to sort of test out my application. I can just run it locally. So think about the Azure emulator as the IS Express equivalent of what we have for IS. So let me show the compute UI. And so this is the worker role running in my application. So right now, it's logging all of the events that it has. In my code, I was basically writing to a trace line whenever a new pizza order came. So if I go back to my web application, and I say fire off a sample order, at some point you'll see in this console log an entry saying that a pizza order was placed. Now sometimes there's a lag between when you write to the queue and then when you read from the queue. Okay, so we got some text saying that now the order was placed. So what just happened was when I went to my website and I clicked place order, my web app wrote to the queue. And as soon as a message was written in the queue, there was a worker role running in the background that sort of read from the queue and then persisted the changes to the database. So if I go back to my database and sort of query for my pizza orders, you'll see that the order is placed. Okay. So what we just saw over here was we added a middle tier to our web application so that we had a good separation of concern where the processing of all these orders does not happen in the websites, so that once the load increases, I can scale this part of the application as and when I need it. The drawback or not so drawback to this approach is also when I was using the worker role, that means my worker role is sort of hosted up in Azure. And let's say now I have a requirement that for some reason this processing needs to happen on-prem. Like this processing cannot move to the cloud. So how do I do it? Is it even possible? So this is the model that we want to eventually reach, where my website writes to the queue, and the queue is running locally in my case. And there's a worker role running inside my on-prem environment, which sort of reads this information. So I'm sort of locking down this control over what goes inside my on-prem and sort of the cloud. So how can we sort of achieve this process? So the worker role comes and reads the data, and then sort of it stores it onto the database. So let's go back to our project, and let's stop debugging. So let's close this guy as well. I'm going to open another project, go back to my database, clean it up. Okay. Right. So what this project has is basically I've removed the dependency of having a worker role, which runs in the cloud, and I'm sort of replacing it with what I would call like a poor man's service. So imagine this service is running inside your on-prem environment. It's running in your laptop. It's running as a Windows service. It could be anything. And what I've done over here is my data access stays the same. My web app stays the same. If I look at my home controller, I basically have the same code that we saw earlier on. And the only difference is instead of the worker role, I'm processing all that information as a service. And in this example, I basically have a console application. And I've copied the exact same code. Like, it doesn't have to be the exact same, but I just sort of picked it up and just put it over here. I have the run method. Inside the run, I basically keep on running it forever. Whenever there is a message on the queue, I sort of read it, and I sort of persist it in the database. So let's run this application as well. Does this kind of make sense? Like, do you have any questions? Okay. Okay. And this is my service. So in this case, I have no cloud project, so I'm not launching any emulator. And then if I go back to my website, send an order. Working. This guy, the web app, puts the message on the queue, and my service sort of reads from the queue. And if I go back to my database and sort of make the call to read these orders, again, so I get the same result. So in this case now, the processing is happening on-prem. It's no longer happening on the cloud. It's the only thing that exists on the cloud is my website, and that's it. So something else I would would like to point out over here is when I'm using my queues, I'm using a local environment as well, just for my own demo purpose. Like, what I'm basically doing is I'm looking up in my app settings, and I've set my queue to be a local storage account. You can obviously replace it with an Azure key as well. So that would mean that your queues are not, the data is now going to go to the Azure. For the purposes of these demos, I'm keeping all of this information inside my local environment. So let's switch back. Okay. So this is all good. So we started with an application where a user could come in and they could place some orders for the pizzas, and the orders were getting stored in the database. And then we moved a step to say, okay, let's remove this dependency of processing the orders in the site, and let's have a layer, a tier for this particular processing. So we introduced a concept of worker roles. But then worker roles were getting processed on the cloud. So we say, okay, what if I wanted to move my processing on-prem? Okay. So we replaced the worker role on the cloud and sort of hosted it as a Windows service so that processing happens on-prem. So which is good. I think at this point, we sort of have the groundwork done to do the big things now. So think about the app again. And what happens in this app is a user comes in and then places an order. And in the background, many things can happen. Once the order is placed, let's say the order, instead of directly going to the store, it goes to headquarters. And the reason it might go to some headquarter processing is because the address needs to get verified, or the credit card needs to get verified, or the inventory needs to get checked, or the load has to get checked on what pizza store needs to take up this order. So there's a layer of messaging that needs to happen in an on-prem environment. Like, once somebody places an order, the headquarter needs to know what order came through. The pizza locations now need to know what the headquarter is doing with that information, and sort of some messaging has to go back and forth. And eventually, some result has to go back to the client, to the web application to say, like, this is what happened. And so the concept that I'm introducing over here is messaging. And Service Bus is one great way of implementing this kind of messaging system. So Service Bus has this concept of topics. Actually, have people used Service Bus? Okay, just one. Okay, so just a quick high-level segue. I showed you how I was using queues, where my web app would write to a queue, and then a worker role would pick up this information from the queue and then process it. So it's a very bare-bones system where somebody reads and somebody writes, and that's it. That's the only functionality a queue provides. Where Service Bus sort of shines is it has a notion of topics. And by topics, I mean like it can figure out, you can set up a system in such a way where you can say, I want to monitor any information that comes for a pizza which has an ingredient of chicken. So that's one topic. And so you can write an if-else clause around it and do some custom processing on these messages that come through the system. So that's the key difference between queues and topics. Like queues are bare bones. You just keep reading and writing. Where topics, you can have some more processing on the data that's getting published and subscribed. And the other great deal about Service Bus is it follows a pub-sub model, which is like publish and subscribe. So there's a bus that you can publish information, and any of the subscribers can listen for it, and then they can process on it. So in my pizza application, that means basically like my headquarters is the guy who's sort of publishing all the information, and all of the pizza locations have subscribed for that information, and they can listen to what's happening, and they can act on it. So that's what Service Bus sort of lets me create in this particular environment. So let's see this workflow on what is possible. So I have my websites, which is still on Windows Azure. It publishes the result. It publishes the information on queues, and then I have a worker role, which is running as a Windows service. It reads from the queue, and then publishes the data on a service bus. Okay, so that's what happens, and all this processing happens in the cloud. Once the information is published on the service bus, there's an application again, which is running in my on-prem environment, which is subscribing to all of the notifications on the service bus. And whenever there is an information on the bus, the subscription gets notified, and the application does some processing, and then there is an on-prem app which can do something. So in our case, it's going to be, let's say if a customer ordered a pizza, then there's a pizza location, and in the UI on the dashboard of the pizza location, it can show that a pizza just got ordered, please act on it. Or these are the number of orders that you have, this order is in process, this order has not started. So that's what the on-premise app can do. Like it can read that information and it can do something on it. So let's see how this is possible. I'm going to switch back to my service bus topics. Go back to my database and sort of clean it up. Okay. So let's close all of these. And let's walk through the code from the last example that we saw. So in the last example, what we saw was a website, worker role, which is on-prem, and then the worker role reads information from the queue and then stores it in the database. So let's see the additions that we've made in this application for the service bus. My data access stays the same. I'm still using my POCO classes, EF, all that stays the same. In my infrastructure, now I have a service bus helper, like similarly as to how I had storage helper for the queues, now I have a service bus helper. And the service bus helper, again, does the following. It initializes itself, so it reads from the app settings, the issuer, key, namespace, and it creates a service bus connection. I won't show you these keys because these keys are basically my passwords. But basically, it goes and talks to the live Azure portal. And what the topic helper does is it does the following. It sort of initializes the service bus, so it sets up the service bus environment. which is basically reading up the keys from config and making a connection to the service bus as well. And also, this is my own code. This is not the recommended pattern that you might follow. So just read the code with a caveat. And the two important methods that are there on a service bus is subscribe and publish. So somebody can publish on the service bus, and the subscribers can read from the bus as well. So the publish helper looks like the following. I set up my service bus environment. I create a topic in the service bus. In my case, the topics are going to be basically the pizzas. And the usual workflow that we have is like somebody goes to the Windows Azure portal. Let me show you that as well. So you go to the Windows Azure portal. You can select this node called service bus. And over here, you can create as many service bus as you want. So I've already created one service bus. And within a service bus, you can have different topics that you can listen to. So I've already run this demo a few times, so this topic is already created. So usually you would go to the portal and create all of these entries yourself, but for the purposes of this demo, I'm creating it in code itself. So I create a topic, and then once there is something, once a user or an action publishes to the service bus, I basically send that information on the topic client, and that's it. So that's what publish does. The other important method is subscribe. And subscribe kind of looks like the following. Again, sets up the service bus, set up the topic names, the subscription name. And the key method is basically add all the subscribers and then call a begin handler. And the begin handler basically, again, goes deep down into service bus intrinsics. So I'm not going to spend too much time into that, but basically, every 5 minutes it checks. Is there anything on the bus itself? And so for an app developer, the usage is the following. So remember now the model is my web app is going to write to my queue, and there's going to be a Windows service which is going to read from the queue and then push it out to the service bus. So my web app doesn't change. Like my home controller is, again, writing to the queue, but my Windows service will change. The change that happens over here is it reads from the queue, and then once it's read, it basically publishes the information on service bus. So that's the key action over here, which is different from what was before. So an order got placed on the queue, an order got read from the queue, and order got published onto the service bus. So somebody can take action on it. And we will look at what the action looks like. So what happens is when somebody publishes on the service bus is I now have my on-prem app, which is basically a WPF app. And you can think about it as the app that's going to show you all the pizza orders in your application. And in my application, I'm basically subscribing to the service bus. So I'm subscribing to any notifications that come from the service bus. And if there is a notification, I show it in the UI. Bonus points. What does this code do over here? Anybody done WPF development? Yes.
So you add the order into your list shown on the screen?
Yes. Awesome. Great. Thank you. I struggled with this about for a day and a half the first time I learned WPF, so I will never forget this. So that's so getting back to our flow. That's what the model will kind of look like. And let's run our application. Oh, one more thing. I introduced this new project called Service Contracts. And currently what this has is basically, if you think about models, there are like basically two kinds of models that you can use in your applications. There are DTOs and there are actual models that you can do with SQL. And so DTOs are basically data transfer objects, which you can use to synchronize your views with. And so I've written my DTO for my WPF app. So this is what service contracts does over here. So I'm going to start all my applications. So this is my website, where a user can come in and sort of place an order. Then I have my Windows service. And lastly, I have my on-prem app. Okay. Let's stack up these windows on the side. Oops. Okay. So if I come over here, and I sort of, once I place an order, it's going to get written to a queue. There's going to be a Windows service, reads from the queue, writes it to the service bus, publishes it, and then my WPF app subscribes to all those notifications, and it can read it. So let me place an order. This is being a text, your order was received, and in my WPF UI, you can see that there's an order over here. If I can go back, I can place multiple orders, and then you will see this processing happening and then the UI getting updated. So that's sort of the workflow that is happening in the background. I tried my best XAML UI skills to make this look like a pizza slice, but it does not, clearly. The colors apparently, hopefully match. So again, just take a step back and make sure that you understand what happened was on the UI, on website, all I did was place an order, which sort of wrote it to a queue. There was a Windows service running in my on-prem environment, which read from the queue and then published it to the service bus. Then there is the WPF app, which is listening for all the subscriptions, and it updates the UI. And so in this demo, this is not doing anything meaningful with the information. All it's doing is showing you the list of orders that got placed. And if you sort of take a leap of faith, what's going to happen is the pizza place can now sort of see what's coming in and sort of optimize their workforce around it. Okay. Any questions? Yes?
In this scenario, say it's your on-premise environment that has to validate that the order is okay.
Right.
In this case, how do you get return some feedback to the website?
That is my next demo.
Nice.
You're reading my mind.
Just returning a message to UI.
Yes. 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 That is exactly what we're going to talk about in my next. And so the concept that I'm going to introduce to you is called service bus relays. And then the scenario that we want to cover is exactly what this gentleman mentioned, that, okay, what I showed you in the last demo was I have my website, I place an order, there's some processing that happens, and there's some publishing of data on a service bus, and my app reads it. But now I need the feedback to go back and send some information to the site. Like, let's say the order was wrong, or the credit card was wrong, there was no inventory, or for the simplest case, I think what I really want to say is, as soon as the order is placed, like as a customer, I want to see in real time what is the status of my order. Like, is it baked? Is it ready? Is it shipped? How long will it take? Like, I really want to know that. So what I'm going to enable in this scenario is I have a feedback loop which is going from my on-prem world back to my cloud. So that's the cycle that we'll follow. Like, so far that we've been going from the cloud into the on-prem, like that's where the data is getting pushed in. And now we're going to push the data out from an on-prem to a cloud environment. And if you think about the scenario, it's a little more involved on what needs to happen if you were to do it. Like, you have to bypass firewalls, you have to bypass security. Like, how do you do that? Like, it's impossible to do it. And what happens in Windows Azure is there's a concept called service bus relays. And the whole idea behind service bus relays is you can expose your data or information which is on-prem to consumers which are outside of your environment in a secure way without having to break your head with firewalls. So that's what service bus relays does, and that's what I'm going to show you. And the way Service Bus Relay work is it's a WCF service which is sitting inside your web application. And the endpoint of the WCF application is inside the service bus. So bear with me, like it'll get a little more clear. So there's a WCF service sitting inside my web application whose endpoint is the service bus. And the service bus is an endpoint which I trust. And that's why my on-prem pushes out the information to the service bus, which then relays it over the WCF connection. So that's why you don't have to break your firewall rules or your security policies and stuff. And that's how service bus relays work. So let's look at what the flow would look like for this particular scenario. My website is hosting a WCF service inside the web application whose endpoint is a service bus. So once an application starts, the WCF service starts, it connects to the endpoint in service bus. The second step that happens is my on-prem app, which is, think about my WPF app, basically. When it starts, it basically connects to this endpoint on the service bus. Okay? The website then sends a message over the WCF service to the service bus. And the service bus has intrinsic knowledge that this message came over the WCF service, so it relays this message to my on-prem application. And the keyword is like relays, this information over to the on-prem application. Then the on-prem application does some processing of the data, and then it pushes out a message to the service bus. And once the service bus gets this message, it relays this information back to the website because it's basically a WCF service. It's sitting in the pipeline. Okay? Did the workflow make sense? Or should I go over it again? Okay, so let me continue with the app, and I'll reiterate what this flow kind of looks like, and I'll show you the different parts of the application which sort of make it possible. Okay, so let me go back and let me close my previous demo. Let me also clear my database. Okay. Close all the files. Okay. All right. So I have my data access layer, which is the same. My infrastructure libraries are the same. In my service contract, I have now defined a new service, which was not there earlier. And it's basically an order status service. And the scenario that it's going to enable is a user went ahead and placed an order got submitted to the pizza store. And as the pizza store guys are churning through the order, at different steps, my website is going to get some notifications what the status of the order is. So that's why it's an order status web service. For folks, have folks in this room done WCF services? Or just 1, 2, 3, maybe? Okay, 4. So these are standard like service contracts and operation contracts. I basically went ahead and created a type for my order status request because it had more than one field. It's not really required, but that's sort of the contract for the service. And then inside my web application is where I have the service. So I actually am implementing my order status service over here. I have a little bit of SignalR going on under the covers as well. I'm going to touch upon it a little bit. Have people heard about SignalR? 2, 3, 4, okay. Later today, I have a deep dive talk on SignalR, so you guys should attend it. I'll give you a 2-minute pitch on SignalR in this demo. But let me continue with the service. So I have my order status service, and in my application start is basically where I'm instantiating a service host, which creates my service. In my web config, I have all of my configuration for WCF. So this is where I'm defining my services. Let me close this guy. And I have something new in these config section is the net messaging, the TCP relay transport. So this is the service bus relay functionality which is added since I added the service bus NuGet package into my project. So what I showed you was the code on what's the interface for the service, what's the service definition, and how do I start up the service in my application startup. So let's see how the bits are wired up. So I have a service running. So let's see how the WPF app sends the data onto the service and how the web application consumes this data as well. So in my WPF app, I have my button. So this basically tells me that once the order comes, I can click some buttons to say like this order was ready, baked, and stuff. And once it's done, I can call this send order status, which is gonna basically create a service and then call this method. In my web application, what happens is something very interesting. Right here. Okay. So the WPF app sent the message came to the service bus, it's sitting in my WCF service, and now I want to create some sort of real-time feedback into my web application. So as soon as I said in my WPF application that the order is ready, I should get instant notification in my UI of my web application. So I'm using SignalR to create this real-time bridge between my web application and my service endpoints. And the way SignalR works is basically, SignalR is a real-time framework, and it has high-level constructs called hubs. And hubs are basically server-side constructs which can basically send data from a client, which is a browser, to the server, or from a server to different clients which are connected to each other. And so just a quick overview of SignalR. I have my order status hub, which basically has a listen for updates call, which can be called on the server. And so if I, actually, let's hold back a little bit. Let me not touch upon SignalR right away. Let me launch my application because it'll make the UI flow a little more cleaner, and then I can delve down into SignalR. So let me debug and let me start a new instance. That's my web application. This is my Windows service, which is going to read from the queue. And this is my on-prem application. Okay. So let's stack these guys up. Okay. I fire off an order. So what just happened was I placed an order, and then this text got highlighted. I'm using jQuery UI for the animations, but I'm getting sort of these updates from my on-prem application. So my web application submitted an order. It got written to a queue. My Windows service read that data from the queue, published it to the service bus. It went back to the WPF application, and once the WPF application got this data, it relayed information back to my web application. And this relay is the constant feedback that I'm sending from my on-prem back to my web application. So if now you would notice, like, keep your eye out on this text as I update the status of the order. So I'm updating the status of the order in my on-prem environment. And I'm giving the feedback back to my web application, which is on the cloud. So the pizza has been prepared and about to be baked. Pizza has been cooked and about to come home. Pizza has left the building. So that's the feedback that's happening in real time from my on-prem back to the cloud. And then the UI updates that were happening were because of SignalR. Yes?
How did you inform the browser once your web application knew that the data changed? How did the application inform the browser?
So the SignalR, like, that's the part I glossed through, but I'm going to go back and show you how that happened, because I wanted to show you the UI on how it would look like, because that would be easier to understand. So let me show you how the UI update happened. So far you got the workflow of publishing from the WPF app to my WCF service. So I think we're on the same page on that. Okay. So here's how it happened on the web application front. In my WCF service, so this method gets called whenever there's data coming from my on-prem into my service bus, and service bus is going to relay it over the WCF service. So what I'm doing over here is I'm using SignalR to say, so let me backtrack a little bit. The first time I launch my application and I place my order, I create a SignalR connection between the browser and the WCF service. Okay? So the first time I launch my application, this JavaScript runs, and it basically says, start a SignalR connection for this particular application and connect to this particular hub called order status. And order status is a hub that I've defined in my application over here. So this creates a SignalR connection, and what it means over here is basically for the pizza order that I just placed, create a connection between the browser and a WCF service. So any notifications that come on the WCF service automatically get relayed back to the through the SignalR connection to the browser. And so that's why I keep getting all the data over here. Yes?
But then it's the browser that regularly goes to WCF, I suppose. So there's a kind of loop.
No.
So WCF is able to push the browser.
Yes. And so here's the code that pushes it as well. So this is my WCF service. I'm saying whenever there's data over here, I'm getting the context of the hub, and clients and groups are dynamic constructs in SignalR. But what I'm basically saying is get this particular connection and call this method called status updated on this connection on the client. Okay? And my client in this case is the browser, and status update is a method I've defined in my JavaScript. So I'm calling some JavaScript remote procedure calls basically from my server back to my client. And whenever there's an update on the, so each time there's an update in the WPF app, this method called status update gets called. And I'm passing in the string like all the way up from my WPF application to the service bus relay, to the WCF service, to SignalR, and back to my web application. So that's kind of how it all flows through. Questions? Yes?
Not related to SignalR, but I'm curious how come you didn't call the initial order straight to the bus?
Initial order.
The order from the web page, why is it not placed on the bus? Why does it go to the queue, Windows service, then bus?
Oh.
Scales just as well as the queue.
Yes. Yeah. It's just implementation detail. Okay. Any other questions? Does this make sense? Are you guys bored? Okay, thank you.
So if we have this separation like you showed, in Azure there is service bus of the application, and on premises there is our worker
Right.
database. Is there any special configuration required on our side on premises, ports that need to be open and so on?
No. Like, right now I have this application running locally, but I tried it with Azure websites and it works. I mean, that's the beauty of it is like the whole concept of having a service bus relay is for exactly that same purpose. Like, you should not have to open up firewalls, you should not have to open up ports just to enable these kinds of applications.
So the communication is through HTTP, like calling.
Yes, or HTTPS, like whichever one it is, right? Yes.
Maybe we can discuss that after the session. There's still something I don't get, is how the SignalR is able to talk back to the server. So HTTP is stateless. So once you have a request, if there is not something, let's say, looping on the server side, that queries something.
So SignalR maintains that connection between the browser and the service. Like, it's SignalR that's keeping that connection open.
But it's using AJAX behind or even.
Sure. In this, so it depends. Like, since this is Windows 8, it's using WebSockets. But if you were to fall back on, like, say, i9 or like Windows 7, like, it'll probably be AJAX, long polling, or server-side events.
Via sockets direct.
Yes. So it's WebSockets in this case because that's the protocol that both the browser and the server supports over here. Okay. So let me go back to my deck. So what we saw in this demo was sort of a feedback loop from my on-prem assets like back to the cloud. How do I send information, and how do I expose it by the way of service bus relays, so that I don't have to open up ports. My firewalls kind of stay the same. Another construct that I'm going to be sort of chatting to you about is also called data marts. And if people heard this term called data marts, okay. Please help me explain if I get it wrong, because I'm still trying to grasp it. What data marts basically means is, if you think about my application, it's on the UI front, on the website front. I don't need to access all of my database. I don't need to access my order details. I don't need to access my other information about my on-prem, like pizza locations and stuff. All I want to care about from a website perspective is, what is the inventory for a particular pizza store? So that when a user comes in, they say, give me a pizza and give me pepperoni. Is pepperoni available in that store or not? So I basically want very restricted amount of data to be exposed to my web application. And so the scenario over there that sort of builds up is, my database is sort of like terabytes and terabytes of data, which is an on-prem asset, and all of my on-prem apps connect to it and use it. But the customer-facing one doesn't have to have all of that data. So how do I expose this piece of information to my web application itself? And that's this process is called it's called data marts. And so I have my database, I have my application running in my on-prem environment. I sort of push the data to the service bus. Again, it's using relays and WCF services. And this relays back the information to the website. And the website can now talk to this database. It could be another database. It could be the same database, which is on-prem. It totally depends what the scenario is. And so let's see how we can achieve data marts. Let me switch back. So file open project. Let me go back to my SQL. Let me delete the entries. Okay. And so the key table that we're going to play around with is available ingredients, because that's the information I care about from a UI perspective of the web application. So if I query the table, I have this list of ingredients, and some of them are in stock and some of them are not in stock. And the scenario that I want to enable is, in my on-prem world, I basically have control over what this inventory looks like. So I can change this inventory based on whatever happens. And this state of the inventory should be reflected in the database that my web application uses, so that when a customer comes and places an order, they get a realistic sense of what they're ordering. So that's what I want to enable in this scenario. So what I have in my application is a very similar model to what I showed you in my last service bus relay example. In my service contract, I now have a new service, and it's called inventory service. And it basically has two methods: toggle and get the entire list of ingredients. So I can toggle between what's available, what's not, and sort of get the list of ingredients that I have. And I follow the same pattern. In my web application, I implement this service. So in my infrastructure, I have this inventory service. And all this inventory service does is basically it news up the DB context. And the toggle available basically changes the state of the particular ingredient, and then it saves the changes. And the get ingredient sort of gets the list of all the ingredients. Okay, so that's all this service does. I have a similar, I actually have my WPF app, which is modified as well. So let me, and what this WPF app allows you is, as an on-prem asset owner, you can come to this app and you can control the inventory. So you can say what's in stock and what's not in stock. And so let's run my application and let's see what happens. So I'm going to start my web project. And the reason I have to start it is because it's hosting the WCF services. I'm not going to place an order in this scenario. So my application is started. My if not, my Windows service has started as well. And lastly, I'm going to start my WPF on-prem app. Okay. So now this on-prem app has a UI as well to sort of control what ingredients are there in my inventory. And so I can come over here and I can say, I don't have extra cheese, I don't have green onions. And if I drop down to my database and make the same DB query, I get the changes reflected. So what happened was basically I went to my on-prem assets, I changed the inventory, that change got reflected in the database, which is getting used by my web application. And for the purposes of this demo, this database is the same, but it doesn't have to be. I can very well split up the database into two parts, like one is which is available to the public cloud, and one which only has on-prem assets, and I can easily split that up. As the whole point about data marts and this demo is about, I have a way from an on-prem environment to control the information that gets displayed in the public cloud. And how do I expose this data to the public cloud? Did that make sense, like this data mart demo? Okay. Any questions? Okay. So this is right about towards the end of the talk as well. We have some related talks. If you guys are interested, there's a EF talk that happened yesterday. I'm giving a SignalR talk later today in the afternoon. There's a Web API talk, I believe it's on Friday. There's an async talk on Friday. There's a web deployment talk on Friday as well. I'm going to be covering Kudu as a deployment mechanism for Azure. There are some resources that you can look into on how do you connect your on-prem databases or your on-prem assets to Windows Azure, more details about Service Bus relays and some hands-on labs for Service Bus as well. Channel 9, TechNet, the good learning sites that you can browse to. And just some goodies that you can win. Please do complete your evals. It helps a lot for us to sort of evolve our talks and see what is something that people would like to hear. And I have 7.5 minutes if you have any questions, or if you just want to stop by, we can chat as well. Yes?
Just one question about the service. Is there a way to see the number of messages that are in the queue, for instance,
Yes.
of the board?
So there are two ways to do that. I can basically come over here and sort of monitor. So it gives me a graph of how many messages are flowing over the bus. In my case, I guess I didn't have that many to begin with. There's also this cool tool. It's called Cloud Storage Studio. And what it basically does is it provides you with a nice UI in terms of viewing all of your Azure assets as well. So your blobs, your queues, your storage, and you can sort of do queries on these as well, so you can do CRUD operations. So that's another way of doing the same thing that we have. Sorry? There might be. I'm not too sure about it. Like, I can check on that if there's PowerShell commandlets. As part of the Azure, like the Windows Azure PowerShell tools, I think there might be. Anything else? Right. Thank you so much for hanging around, bearing with me. I hope this talk was somewhat useful, and have a great TechEd. Thank you.